Okay, everyone, welcome back. Calculus 3 class notes. We're now on the second page of our section 15.8 notes on substitutions in multiple integrals, and which is page 106, and we're now looking at the definition of the Jacobian for a double integral. So the Jacobian is a determinant. The Jacobian determinant, or just Jacobian, of the coordinate transformation x equals g of uv and y equals h of uv is the Jacobian, which will end up in terms of u and v. So we take the partial of x with respect to u and the partial of x with respect to v in the first row. And then we take the partial of y with respect to u and the partial of y with respect to v in the second row. And then we evaluate this as a 2 by 2 determinant. So I multiply the main diagonal minus multiplying the off diagonal. So that is what the formula is, but it's nice to remember it this way. And then sometimes you'll see its notation as partial of xy with respect to partial of uv. You have to understand that that notation means this Jacobian, which is this 2 by 2 determinant, which in actuality is this formula here. So this sometimes is just notation. So notes, this array of partial derivatives behaves just like g prime in the single variable substitution problem, right? So remember g prime, it behaves like this guy. It's what we're going to be able to say that x actually transformed from this. Okay, so this has a derivative term. So this Jacobian is that like derivative term. And it measures how much of the transformation is expanding or contracting the area around the point uv in the uv plane. Effectively, it converts the area of the differential rectangle du dv in G to match its corresponding differential area dx dy in R. Okay, so theorem. So here's the theorem. Substitution for double integrals. Suppose f of xy is continuous over the region R. Let G be the preimage of R under the transformation x, which is g of uv, and y, which is h of uv. Assumed to be 1-to-1 on the interior of G. If the functions g and h have continuous first partial derivatives within the interior of G, then this double integral actually could have came from this. Remember, backwards thinking. So this double integral is f of x, which is g of uv, and y, which is h of uv, but then I need to add this derivative term. Notice that this is absolute values. It means take the absolute value of the result of the Jacobian by doing that 2 by 2 determinant. So it's the absolute value. Some people, when they first see this, get confused and think it's notation for just the Jacobian, but this is the absolute value of the Jacobian. The proof of this is much better in advanced calculus course. What I want you to be able to do is do some basic problems where we can see how to get these transformations.